In this video, I would like to talk to you about how do we calculate probability. How do we calculate this measure that represents the chance that a specific event or a specific outcome will happen. So, for example, suppose there is a chance that there will be rain tomorrow, and there's a chance that there is no rain. What is the chance that there will be rain? Suppose I have two possible outcomes now, rain or no rain. So the chance that it will rain tomorrow, suppose an expert will tell me that there is a 70% chance of rain. Accordingly, there is a 30% chance that there is no rain. So the probability is this numerical value, this numerical measure, the 70% or the 30%. However, we don't usually use percentages. Percentages is a common for the public. It's common for the public, which we as students or academics working with probability and statistics, instead we use a fraction. So the probability of getting rain, we rather say 0.7. So we just write 0.7. And here we write 0.3. So it's a fraction less than 1 usually, or between 0 and 1. And you notice that if you add these two probabilities, you always get 1. So whatever the outcomes you have, the probability, that sum of the probability at the end will always equal to 1. Okay, so that's it. The probability, yes, it's commonly understood as percentages, but when we as academics use in calculation or in equations, we use the ratios as a fraction part of 1. So that means the probability will be between 0 and 1. And when you add all the probabilities of all the outcomes that you have or all the events that you have, then in any experiment, then you will have 1. So that's a quick idea of what is a probability and the basic rules of probability. Now let us look at different ways of calculating these probabilities and where do they come from. The first type and the most commonly used type is classical probability. So what's classical probability? In fact, all the examples we have seen so far have been classical probability. Consider the coin tossing, the coin tossing having head and tail. This is classical probability. The other example we had is when you roll a die. This is another example of classical probability. So the main idea here is that all outcomes are equally likely. So all outcomes are equally likely. What does it mean, equally likely? It means they all have the same chance of being selected or of being, appearing as an outcome. So all of them have the same chance, all of them have the same probability. That's the main idea of classical probability. And if, for example, the head and tail have the same chance, and the sum of the probability must be 1, then it must be the probability for the head half, and the probability of the tail is also half. So the probability of head, we can say, is half, okay, and the probability of tail equal to half. Similarly, if this is a die has 6 outcomes, and all of them have the same chance, so they are equally likely, and the sum of the probability is equal to 1, so what could be the probability of each one? The probability of each one must be 1 over 6. So that when you add 1 over 6 plus 1 over 6 plus 1 over 6 plus 1 over 6, each one has a probability 1 over 6, and there's 6 of them, so when you add them, you get 1. So from here you can come up with the rule. The rule is the probability of any outcome in the case of classical probability is simply 1 over the total number of outcomes. The total number of outcomes. Okay? So that's the idea. That's the probability of any outcome. It is 1 over the total number of outcomes. So the total number of outcomes here is 2, so it's 1 over 2. The total number of outcomes here is 6, so it's 1 over 6. Each one of them is 1 over 6. So that's the classical probability. Okay, so that's about the probability of an outcome. How about the probability of an event? So now let's get the probability of an event. The probability of an event, for example, what's an example of event? Let's look at the die example. Remember, the die has 6 outcomes, but one of the events could be the even number, and another event could be the odd number. So what is the probability of getting an even number? An even number when you roll a die. Remember, that's the die here. Okay. So what is the probability of getting an even number? Remember, the even number is 2 and 4 and 6. So that's 3 outcomes. So in this case, it's the probability of getting any one of them will be an even number. So in this case, it's either the 2 or the 4 or the 6. So that's 3 outcomes out of total 6 outcomes. So that's half. That's actually 3 over 6, which is half. So that's 3 over 6. Similarly, the probability of getting an odd number, which could be 1 or 5 or 7 or 1 or 3 or 5. Remember, this is 1 or 3 or 5. And this is 2 or 4 or 6. So this is here 3 out of 6. And here also 3 out of 6 outcomes. So this will be also 3 over 6. So that's, in this case, the probability also of getting an odd number. Okay, so that means what? That means the rule is the probability of any event will be the total number of outcomes in the event. So that's number. Okay, let me write that as NO. So that's number of outcomes in the event. In the event, let's call the event E. Suppose this is the probability of event E. Okay, so if this is my event E, it's the number of outcomes in E divided by the total number of outcomes. Total number of outcomes. Okay, so that's the rule then. The rule is the probability of an event is how many outcomes in this event compared to the total number of outcomes. Now, because this is a very common question to ask you about the probability of an event in a classical probability, we really definitely need to see more examples. So let's have a look at another example. Do you remember this example of having colored balls so that each ball has a color and it also has a number? Imagine you select one ball out of this container, one of these balls out. What is the probability that the color of the ball is red? The probability that the color, see, red here is an event because it has 3 outcomes. It could be this red ball or this red ball or this red ball. So I have 3 possible outcomes in the case of red. So 3 outcomes out of total 6 outcomes. So the answer must be 3 over 6. Okay, so that's the answer of the first question. Now, the second question is also an event, but it's different in event. This time you want the probability that the ball carries the number 3. So it could be this ball, the blue one that has 3, or the red one that has 3. So I have 2 outcomes in this event that he is looking at. So 2 outcomes out of total 6. So that is 2 over 6. Okay? Of course, you can rewrite this as, if you want, you can rewrite this as half, and you can also rewrite this as, 1 over 3, but, that's not the issue. The issue is that you need to understand the rule is the total number of outcomes in the event divided by the total number of outcomes, and that applies here as well in any event. Okay? So this example, we have like 2 out of 6 or 3 out of 6. These are really small numbers. Let us see what will happen if we increase these numbers a little bit. Will you get confused or it's still okay? Let's try that. A school has 200 students and 20 teachers. One person is selected from the school randomly. What is the probability that he or she is a teacher? Now, the total number of people where we're selecting from is in fact what? We are selecting from a school that has 200 plus 20 persons, the total is 220. So you need to know the total number of outcomes. And now you need to know the different two types of outcomes. One type could be a teacher, and the other type could be a student. Now, how many students are there? 200. That's 200 out of how many? 220. How many teachers are there? If you look at the teachers, they are 20. So 20 out of the total. So if you want to know the probability of getting a teacher, the probability of getting a teacher or selecting a teacher, that's how many teachers you have, which is 20, divided by the total number of people you're selecting from, which is the whole school, which is 220. So that should be the answer, or if you simplify that, it will be 1 over 11. So that's the probability of selecting a teacher. And this is another example of using the classical probability of an event. So an event that has 20 outcomes divided by the total number of outcomes, which is 220. This will give you the probability of the event. Let us see another example. Now imagine I have this class with 20 students, and you can tell it's 20 if you count 5 plus 7 plus 3 plus 2 plus 1 plus 2, with this distribution of nationalities from everywhere, almost, and then I select one student from this student. Okay, so if you select one student, let's select, should you write that? Select. Okay, so select one student, only one. So now what is the probability that the student is from UAE, for example? So it's obvious. So that looks like what? That looks like you have a frequency distribution table. Now you have a class, and this is a frequency, isn't it? So if you have a frequency distribution table like this, so in this case, the probability of getting any person from any particular class is simply equal to the relative frequency of the class, because the relative frequency is the frequency of the class divided by the total frequency, isn't it? And this is exactly what the relative frequency is, and that's why this is a concept of being that the probability in this case is the relative frequency, f over n, right? So that's the relative probability concept relative frequency concept of probability. So if you have a frequency distribution table and you want the probability, it's simply just the relative frequency. And we can even apply that for quantitative data. See, here you have all this is qualitative data. We can do the same thing for quantitative data. So let us have a look. Suppose my class now is distributed based on age, not nationality. And that's the ages could be, say, from 17 to 19, from 20 to 22, from 23, that's class limits, of course, 25, and then from 26 to, let us say, 28, and then 29, and above, and above, anything above 29. So in this case, then suppose this is my distribution. I think the majority of the students will be here. So suppose I have 10 here. I have 5 here, 2 here, and then I have 1 here, and then I have 2 here. So that's, again, I have 20 students in my class, and I want to know the probability. Of course, we're selecting only one person, just select one student from here. What is the probability that this student age is at least 26? Remember, 20 at least and at most. I told you this is very common. So at least 26 means really it is 26 and above. So 26 and above means in this category or in this category. So that means these two categories together. These two categories together has how many outcomes? It has 3 outcomes. So the answer will be 3 over the total, which is 20. So that's very much similar to the sum of the two relative frequencies, if you can say. But the idea is the same. You have to count the total number of outcomes divided by the total number of outcomes in the event, which is at least 26, which is these two together, divided by the total number of outcomes, in this case, which is the data size. So as you can see, there's so many examples of classical probability. And I'm really afraid the video is becoming long and students don't like to watch videos that are long. But one more last example in here. Let us have a look. 18% of students in a local university are married. Now, one student is selected from this university at random. What is the advantage of knowing at random? That means all of them have equal chance of being selected, and that makes it a classical probability. So keep that in mind. Now, find the probability that the person selected is married, or the student selected is married. Now, I don't know the total number of students, and I don't know the number of those who are married. All what I know is the percentage. And guess what? This is all what I need. Yeah, all what I need is just a percentage. The percentage is the probability. As simple as that. So that means that the answer is the probability the person is married is simply 18%. That means 18 over 100, or 0.18. That's it. That's the probability the person is married. If you want to know the probability the person is not married, will be obviously the other, 82%, which will be 0.82. So that's a very important example. You need to keep that in mind. It will keep coming in chapter 4, 5, and 6, or probably just 4 and 6. So it's very common, important example. Knowing a percentage that part of the society, no, actually 4, 5, and 6. Yeah, it's coming in all of the chapters of probability. So if you know a percentage of the society that have a certain characteristic, and this characteristic here is being married, for example, then the probability, if one is selected from them, having this characteristic or this feature is the same as a percentage. It's just a percentage itself. This is the probability. So that's a very common question and very important to keep it in mind.